Hello, AP Environmental Science students. Let's play some Minecraft. No, actually, we're going to learn about the impacts of mining. Minecraft's a pretty popular game. I know many of you have played it. So you know some things about mining, and I'm going to tell you some real life things about mining and the impacts on the environment and what kinds of things that we mine. So in our packets, we're going to skip ahead on a lot of things. There's so much to know about mining, but I'm going to focus in on the most important stuff that you need to know for the AP test and for the tests in my class. So we're starting, so this is lecture in Unit 5, 5.9, the impacts of mining. And it's module 25 in your books on pages 292 through 298. So our objectives here are to describe how humans are extracting elements and minerals from the earth and describe the social and environmental consequences of mining activities. Because not only is it damaging to the environment, it's damaging to human health. People can get trapped in mines and die. And there is a disease called black lung disease that you can get if you breathe in too many impurities while you are mining. So we're going to skip from page 26 and skip page 27 and go all the way to page 28. All right. So on page 28, it says back to the PowerPoint, the four elements that constitute over 88% of all the Earth's crust. And that's where we're going to start in our notes. Okay, so the chemical composition of Earth's crust. This is one of those things that you have to memorize. You're going to have to memorize the top most important elements or most abundant elements in the human body, the most abundant elements in the Earth's atmosphere, and the most abundant elements in the Earth's crust, because they ask you this question on the AP test. So the most abundant element in the Earth's crust is oxygen. So that often people find confusing because you think of oxygen as air. O2 is a gas that we breathe. But it is also an important chemical that is in all kinds of oxidized minerals. So calcium carbonate has a lot of oxygen. Silicate has a lot of oxygen. Phosphate has a lot of oxygen. So it's covalently bonded oxygen. So it's the most abundant element in the Earth's crust. The second most is silicon, then aluminum, then iron. So Fe is iron. Now there is a kind of silly acronym for this. I'll tell it to you, but I'll tell you the easier way to remember it is it's only silly apes. And then ferrous can also be iron. So in college, study, like sodium, past, because that's potassium, midnight. And then, I don't know, you can do the rest of these, but there's not very much of that. So only silly apes in college study past midnight is a way to remember the elements in the Earth's crust. But really all you need to remember is only silly apes I suppose. But only silly apes will help you remember oxygen, silicon, aluminum. A little mnemonic for you. And you are writing that down, the top four elements: oxygen, silicon, aluminum, and iron. Okay, so what is ore? Ore is concentrated accumulations of minerals from which economically valuable materials can be extracted, like metals and salts and sand. That's what ore is, O-R-E. Metals are elements that can conduct electricity and heat, energy, and other functions. So copper, nickel, aluminum, and gold can all be used for things in silicon chips and all kinds of different heat transfer and electricity. We'll go into that some more. And then reserve. Reserve is the known quantity of a resource that can be economically recovered. So we know how many reserves we have of a certain kind of ore or a certain kind of metal, right? That is reserve. Now we're going to talk about the different kinds of ores. So maybe you know this from Minecraft, but high-grade ore contains a high concentration of the desired mineral, and then the low-grade ore contains a lower concentration. So as you are mining, it's very nice to be mining through and finding high grade ore because you don't have to go through as much material. So it's much more economical to go through high grade ore. So then the question in your notebook, in your notes, is what would be the environmental impact of having to start mining lower grade ore as we run out of high grade ore? So that's something you can think about. As we run out of high grade ore, we'll be having to go get the low grade ore, which is much harder to go get and has a lot more environmental impact. Okay, so you can pause and write that down. So we're going to skip the article, which is what are the world's scarcest materials. You can look at that if you'd like to, but it's not required. And then we're going to start talking about mining techniques. So how much is left of all of these metals? So not much. We are running out of metals and we're using them up. So finding out ways to recycle and recover metals is actually a really great way to extend our reserves. So here's two main mining techniques. There's surface mining, which is used mostly for coal and copper, and then underground mining, which is also called subsurface mining. So subsurface mining is used mostly for lead and zinc. So those are the mining techniques that you're writing from the little arrows that are pointing out, okay? And then we're going to talk about the stuff that comes off the mining, because for one, you destroy the earth when you dig into it. And for two, you destroy the environment when you wash the things away. So spoils and tailings are the term for the large portions of soil and rock that are removed to access the ore. And then the slag is the remaining waste after the ore is removed. And these are very toxic and very harmful to the environment and need to be properly dealt with. But there's so much volume, it ends up being something that's difficult to deal with and expensive to deal with. And the whole point of mining is to make money. And so dealing with the environmental impacts ends up having a lot of problems. All right, spoils or tailings, and then slag. So here's the types of surface mining. There's strip mining, which is removal of strips of soil and rock to expose the ore. So you can kind of see that here. It makes a little terracing kind of a look. That is strip mining. You remove material, extract resources, return mining spoils and tailings and unwanted materials. So you can like get all the ore out and then just put everything else back there, put everything back that you had from before. Okay, so you're writing these down in the types of surface mining. Number one is strip mining. And so mostly this is used for coal and for sand. Open pit mining uses large visible pits or holes. This is used when the resource is closer to the surface, like copper. So you dig these amazing, enormous pits. They're really impressive to look at. And so I'll be showing you guys some pictures along the way, and then you can just look up some stuff too. These are just incredible things that we do to get these resources. Now another one, hey, why don't you just remove the mountaintop? It sounds like a joke. I wish it were a joke. Mountaintop removal. So basically they explode the whole mountaintop off so they can get to everything underneath. Talk about environmental damage, right? So mountaintop removals with explosives. The tailings are deposited in other regions because the whole mountaintop's exploded, so it has to go places. And so, you have a whole mountain here, and then you explode that mountain and get rid of all of it. And so incredible environmental damage with mountaintop removal. Placer mining is looking for minerals and metals in rivers and streams. So diamonds, tantalum, gold. So the California gold rush, this is what happened with the placer mining. So you are going to sift through. This is the kind of stuff that maybe you've been able to do if you go panning for gold. That's a pretty cool thing to do. And then that's what the California gold rush was all about, running things through sluicing. Okay. Now we have subsurface mining. Okay. And subsurface mining is on page 30 where you're taking your notes. Resources are below, more than 100 meters below the surface. So you can't just dig things off and push them away. You have to burrow down. And this is the classic mining that we often think about, where you can have really terrible, awful disasters. And things are much safer now than they used to be, but many people have died along the way for getting these resources out of the land for us. So it's much more expensive. Coal, diamonds, gold, horizontal tunnels are drilled in vertical shafts and elevators. So some types of mines, so they'll have vertical shafts and a single stage hoisting mine. You might have a slope mine so that you can get down there. And then you're constantly going to try to find the undiscovered ore. So you have a little picture of that in your notes, okay? To kind of get that idea. And in your book too, there's lots of good information for you. Okay, so the impacts of mining. So let's see. So what did we write down there? So more than 100 meters below the surface. It's much more expensive, so it's only used for coal, diamonds, and gold. So it's got, the expense has to outweigh the return that you're going to get. Otherwise, nobody would do it. Okay. So air. So the environmental impacts of mining don't just affect the land, they affect everything. So we're going to talk about the air, the water, the soil, biodiversity, and human health. We'll be doing the same thing for how food has environmental impact. So this is going to be really important. You always have to know, for any big thing like mining or food production, you're going to have to know the impacts on every part of the biosphere. So there's dust particles, methane, carbon dioxide from all the fossil fuel emissions, because it takes a lot of work to carry all those things out and ship it all around where it needs to go. Water contamination as it percolates through the tailings. So as the water is coming through, as it rains and there's just normal water movement around, it will leach the minerals out, it leach all the bad chemicals out and take them into the water. Soil removal, and sometimes replacement of a loss of vegetation increases erosion. So when you take out any plants or lots of soil, then the remaining soil is much more prone to erosion. You have huge losses of biodiversity. So you have habitat destruction, degradation, road fragmentation. So habitats are destroyed, therefore decreasing biodiversity. So the effect of mining on biodiversity is to decrease it. And then human health. So there's respiratory disease like black lung and cystic fibrosis. There's also mercury poisoning. So there's a long history of us the major impacts on black lung disease. And we've done much work within the coal industry in particular to decrease black lung disease. So it's much safer now than it was, but it's still not safe, and it's much more expensive to do it this way, which kind of gets us to the point where it's like, why do you still use coal at all? If you're going to do it safely, it's very expensive. So like I said, there's a long history of coal miners having to stand up for themselves to prove that they were being affected by the coal mines, and that was having a long-lasting health impact for them. So there is an article that explains that, which we'll get back to. I think we're going to be able to skip that one because it's enough to know that it is a big problem. And if you're interested, you could look some more at that article. Okay, so mining legislations, because so many people were dying, we had to make laws to make it so that the industry would invest money to save people's lives while they can still make money. So you can make a whole lot of money on mining if you don't do anything to help the environment or anything to help the people that are working for you. But there's going to be pushback because the people won't work there if they're going to be killed. So that's where the law comes in. So one of our big laws is the Mining Law Act of 1872, which is the General Mining Act, and it allows individuals and companies to recover ores and fuels from federal lands, and there's few provisions for environmental protection. Okay. Then the next mining legislation, this is one of the ones that actually had some teeth to it, the Subsurface Mining Control and Reclamation Act of 1977. The land must be minimally disturbed during mining, coal mining, and then reclaimed. So this made reclamation part of what you had to do. So there's other related legislations like the Clean Air Act, the Clean Water Act, the Superfund Act, and we will be learning those laws. We'll do a little activity on that along the way here. It's because you need to know about just some laws, not every single environmental law, but some of the big ones like these listed here. So the big thing that you had to do with the Surface Mining Control and Reclamation Act was reclamation. So when you mined an area, you had to reclaim it. Now, reclaim is different than like replace and repair, okay? You didn't have to restore it to its natural habitat. You didn't have to replant every single tree, but you couldn't just leave it decimated. It had to have a plan to be used for something else. So often, a mining area, once it has all been mined out, could be switched into a place where people could live or switched into a place where people could visit, and that there couldn't be any chemicals there that were dangerous for people. So mining reclamation was a big deal that came out of this law. Okay, so now what I have, this video that you could watch, which is the video that's linked on your page. If you wanted to watch it, you could. This is basically a trailer for a movie called The 33. And The 33 is a movie about the Chilean mine disaster that happened in 2010. So for like 69 days and between August and October, there were 33 men trapped in 2010. This is recent. 33 men were trapped in a mine in Chile. And luckily, they were all rescued, but it was just a horrible disaster. Coal mining has a lot of negatives for the environment, and we will continue to talk about how bad coal is for human health, biodiversity, land, air, and water. Thanks for listening.